This is Math 10.4 problem solving. We're going to take a look at our first one. Given triangle ABC is congruent or similar to triangle DEF, we want one rigid motion followed by a dilation with the center of 0, 0 to find the possible coordinates for D. So we want to know where D would land. On your paper, you have two different methods, two different boxes at the top. So you're going to use one for method 1 and one for method 2. The first one, for method 1, we're going to translate our ABC down 2 units. So you can see this is our new one. It is in blue right here. I'm making it green. So we've translated it down, and then we're going to dilate its image with the center of 0, 0 and a scale factor of 2, which means every single one of these we're going to go ahead and multiply by 2. So A prime right now is at 1, 1, and when we multiply that by 2, we're going to land at 2, 2. So that's where D is, right here. It is in green. If we do that, we can also look at B prime, and it is at positive 1, negative 1. And when we go ahead and work that one through times 2 on all of that, we're going to land at 2, negative 2. And you can see that is where E is at right here. And C prime, we're going to land in the same spot. We've got 4, negative 1. We're going to multiply that by 2, and we're going to land at 8, negative 2. So that is where F is right here. I've enlarged the screen so you could see all of my math on the side. So that gives us D at the possible point of 2, 2. Okay, the other method is to go ahead and take triangle ABC and reflect it across the x-axis. You can see the x-axis right here is our dotted line that goes across right here. We're going to reflect it across, and we have ABC prime right down here. Then we're going to dilate its image with a scale factor of 2, which means we're going to do the exact same thing that we just did. Taking each of our points times 2. You can pause and work that one out, and then I'll show you where it all lands. That's all the work there. And then we're going to go ahead and notice that our D could possibly be at 2, negative 6. So now we have two different options for point D, and you should have drawn them both out with the work on the side. This one is very similar. So we have triangle JKL, and it is similar to PQR. We want to know what are our possible points for R, and they've given us 4 options. Once again, you have 2 different boxes, so I want you to draw out and write out what we're doing for each one. So our first method is to translate it 7 units to the right and 3 units up. So we've started with the black one and we've landed with the blue one. You can tell that because of the prime signs. Then we dilate its image with a scale factor of 1/2. So we've multiplied each of those by 1/2, or you can use what we did in 10.3 where we have shrunk them down. And that shows us that the dilation maps vertex L prime to possible points for R. And that means that R has the option of perhaps being 1, 0. Okay, for method 2, we're going to apply the same translation and dilation as before, which means that we're going to do exactly the same thing. We're going to go ahead and translate it 7 units to the right and 3 units up. Then we're going to take our scale factor down to 1/2. Once we have that, then we're just going to go ahead and reflect it across x equals 3. So we're reflecting it across this line right here, leaving us a new PQR. on this side and leaving us our possible point for R at 5, 0. So those are our two possible points. One of the things that you can use is a scale factor in scale drawings, and that will help us. So this is a scale model of someone's house, and we want to take and find out what are the dimensions of the actual bedroom. So on your paper, I have gone ahead and moved the ruler over, lined it up. The 0 should line up right with one of the walls. So we can see that the bedroom is 2 inches wide. Now that we know that information, we're going to go ahead and take our scale drawing. Our scale they have given us right down here at the bottom, and we're going to put inches over feet. It's important to put your units so you can keep your units in mind as we're moving. And every 1 inch represents 8 feet. In this particular case, this is 2 inches long. So I'm going to put my 2 on the same side as the inches because it is an inch. And then I'm going to just see 1 times what is going to be 2, and that's 2. So whatever you do to the top, be fair and do to the bottom. So we're going to find that this wall right here is 16 feet long. Now that we know that, we're going to go ahead and find how wide it is. So we're going to take our ruler and we're going to turn it. And we're going to measure. Once again, I'm putting the 0 directly on one of the walls, and so I can measure from there. And it looks like this one is 1.5 inches long. I'm going to use my exact same setup over here. So I have the inches and the feet. My inches are 1 to every 8. In this case, the inches are going to be 1.5 because I know that. So now I need to find out how am I going to get from 1 to 1.5. I'm going to multiply it by 1.5. So I'm going to multiply the bottom number by 1.5, and I'm going to get 12. So my dimensions is that it is 16 by 12. So now we're going to make a scale drawing of your bedroom. You decide on a scale of 3 inches to every 4 feet. And your bedroom, they tell you, is going to be 12 by 16. So once again, we're going inches to feet. Inches are 3 and your feet are 4. In this particular case, we know that your bedroom is 12 foot long. So we're going to take each one independently. So I'm going to go ahead and put this on the feet side because it says feet. So I'm going to correlate that with my other feet. And I'm going to say 4 times what is 12? Well, 4 times 3. Whatever you do to the bottom, you have to do to the top because that's only fair. So that makes it 9 inches long. Then I'm going to put that exact same model in, only this time, as I'm looking at it, I'm going to look at my 16 feet. So 16 is feet. It's going to go on the bottom with the other feet. And I'm going to say 4 times what is 16? Well, 4. So I'm going to go ahead and multiply the top by the exact same number, and I'm going to get 12. So on my scale drawing, my dimension should be 9 inches by 12 inches. Another way that you can use the fact that corresponding sides of similar triangles are proportional is to help you find lengths that you cannot measure easily without using a ruler or another measuring device. So this is indirect measurement. Let's go ahead and get an example of that. In this, we're going to use the exact same information that we have just used. So my friend wants to find the height of a building, and the building cast a shadow 15 feet long. My friend cast a shadow of 3 feet long. And we want to know, with that information, if my friend is 5 foot tall, what's the height of the building? So I have 2 things. I know the shadow, and then I also know the height. Okay, I know both of these things of the same thing, which is my friend. So my friend I'm going to use as my scale. My friend cast a shadow 3 feet long, so that's her shadow, and she is actually 5 foot tall. So her actual height is 5 foot. Now I'm going to take a look at the building. And the only thing that I know about the building is that the shadow is 15 feet long. So I'm going to go over to my building section along the shadow, and I'm going to go ahead and say that's going to be 15. Then I'm going to say 3 times what is 15, and that's times 5. So I'm going to multiply the height of my friend times 5 to get the height of the building. And I'm going to say the building is 25 feet high. This is exactly the same as the last one. So I'm going to have you hit pause and try and work it out on your own, and then come back. Okay, with that having been done, let's work through it one more time. We have a shadow, and we have the height. And we first want to know, we have to have the same thing. We know that a vertical post, what its shadow is, and we also know how high it is. So we're going to take our post and we're going to look at it. It casts a 3 foot shadow. So I'm going to put that under the shadow, and it is 4 foot tall. So I'm going to put that there. Then I'm going to look at the tree. The only thing I know about the tree is the shadow. So that's going to go in the shadow section under the tree. Then I'm going to go ahead and say 3 times what is going to be 24. That's times 8. So I'm going to go ahead and times 8 on the bottom. I'm going to get 32. So the tree must be 32 feet tall. Okay, I hope you've taken really good notes, written everything down, and are ready to jump into your homework.